Greetings everyone. Today I'll be explaining my task of performing time series forecasting of the air quality index in Delhi using LLMs. So this was the task proposed for the project of IIT Gandhinagar, a research program. Let's understand what air quality index is. Air quality index is nothing but the worst sub-index from all the subparameters calculated using this particular formula. This particular formula is given by Indian standards, which has all the explanation like BPHI, BPLO, which means the higher and lower range of the particular concentration at that point of time. The IHI and the ILO is the corresponding value of the AQI. So we'll be using this formula to calculate sub-indexes for different pollutants like PM 2.5, PM 10, nitrogen dioxide, sulfur dioxide, ozone, and carbon monoxide. So basically, these parameters are the most contributing towards the AQI. That's why we selected those parameters, and we'll be calculating the sub-index using this formula. And we'll be having the reference from Ministry of Environment and Forest that what AQI is satisfactory, what AQI is moderately polluted for what range of different pollutants. Let's look at the data. Here we selected the Ashok Nagar data of Delhi. We have 122,000 rows for the last 6 years, and the precision is half an hour. We have data for every half an hour of different pollutants, but we are only interested in the best 6 pollutants that are these columns. So we'll be taking the data for the past 2 years, that is 2021, 2022, 2023, past 3 years. Yeah. So for example, what we are doing here is we're understanding how every particle matter is ranging in a particular year. This is a particular day. Yeah. So on 31st December, at every half an hour point, we sampled that what particular matter, what SO2 levels are on that particular hour. So we analyzed that these three lines, that nitrogen dioxide, particulate matters of 2.5 and 10, and other three are most contributing towards the air quality index. So what we selected is to analyze and to keep only those parameters in the game. And here we used this sub-index formula, and the best and the worst index which will be calculated by this formula will be the AQI for that day. We'll be taking about the averages. So we calculated the average of different columns. There's a catch between here is that ozone and carbon monoxide, for that the reference says it's of 8 hours. The others, while the others are of 24 hours, the carbon monoxide and ozone reference is of 8 hours. So we calculated the average of 8 hours for that. Coming to the point, we calculated the sub index here and the output here. So this output is supposed to be prompted to the LLM running on the Ollama, and then we have to zero shot it for predicting for the next 24 hours. So what results did we got here is this. We used the Gemma model here because the time GPT and time LLM were heavy for the machine I'm working on. So we used Gemma, but all the language models are capable of identifying trends between the time series data. So they can identify to a certain extent. But those time GPT and time LLM are specifically made for time series forecasting. So I gave a little index for forecasting here, that I gave the 31st December values, that 391, that 317, and told the model to predict for the next day, that was 1st January. So it predicted for 1st January. The predictions are as shown here. Let's now analyze how correct it predicted. So we use the 1st January data and we calculated the same again. Here we got PM 2.5 as 337. The PM 2.5 is calculated as 402. So you can see that it is not very correct. Yes, to some extent it can predict. And basically it also matters with that, for example, 31st December was a new year. So it is bound that more air pollution was going to happen on that day compared to the next day. So these contexts are not given in the zero shot prompting. That's why there is a chance of error. This is the data we extracted for that. And we also analyzed for different dates like 19th December, for 19th December and 20th December. Again, we calculated the same thing. We have a look at the graph. Again, we observed that these 6 parameters were contributing to the most of the AQI index. We calculated this average. For this, when we ran about the gamma model, it was showing the hallucination. This is because the machine is not yet capable enough. But rest assured that the zero shot prompting can be easily done on TimeLLM and TimeGPT models, which will be able to run on higher end machines. So we understand this by looking at the data for 19th December, and let's look at the data for 20th December, 1st January. Sorry, 20th December. See, 342 and 337, 317 and 342. There is a little jump. So that's about it. We understood how to prompt the models on Ollama for time series forecasting, zero shot prompting. And whenever we give a little context, like in this case, that we gave Ashok Nagar in Delhi, it is for 31st December, and we used PAP, which is for prefix as prompt. So this is the technique known as PAP. So it gave correct answers, but for zero shot prompting, different model may give different answers. Coming to the code base, here is the code base. Here we can see all the methods and how to run this particular thing, the Ollama serve and Ollama Gamma 7B model. I've also mentioned that we can use these two models if you are using on the high-end machines, or we can use Google Colab Pro versions for Colab and Gaggle for cloud-based GPU. So this was the whole code to go through about the task I was given. Thank you.